going to solve this problem. So most of you had a lot of difficulties understanding this exercise and didn't do it right, okay? So let's go step by step. The first thing they ask us to do is to identify the kind of motion in each part of the motion. So we can clearly identify three parts. The first one, the first 20 seconds, where velocity is increasing. So it goes from 0 to 40, okay? So velocity is changing, and so that means in part 1 we have a uniformly accelerated linear motion, and acceleration is bigger than 0. Because velocity starts being 0, then it's 10, then it's 20, then it's 30, then it's 40, okay? So uniformly accelerated linear motion. Now let's go to part 2. So part 2 goes from 20 to 30 seconds. So we can see a clear change. A lot of you said there is no motion in here, but that is not true. The thing that happens is that velocity starts being 40, and then 1 second later velocity continues being 40, and then 40, 40, 40 until it reaches the 30 seconds. So velocity is constant. So constant velocity means uniform linear motion. Uniform linear motion, okay? Then let's go to part 3. So in part 3 we start with an initial velocity of 40 meters per second, and then we go lower and lower, so 30, 20, 10, 0, okay? So this means velocity is not constant. This is a uniformly accelerated linear motion, and acceleration is smaller than 0, okay? Let's write it in here. Uniform linear motion, uniformly accelerated linear motion. Acceleration bigger than 0. Uniformly accelerated linear motion, acceleration smaller than 0. Okay? I hope you could understand it clearly, guys. Now let's go with part B. So part B is one of the most difficult ones that I ask you to do, because in part B they ask me for distance travel when time is 30 seconds. This is a bit difficult because time 30 seconds covers two parts. First one from 0 to 20, a uniformly accelerated linear motion, and then the second from 20 to 30, uniform linear motion. So we need to consider that, which none of you did, okay? So in part 1, we have a uniformly accelerated linear motion, and distance travel follows this equation, okay? So this is the equation we need to use for distance travel. We can imagine the initial position to be 0. So initial velocity from 0 to 20 is 0, okay? And 1/2 over acceleration times square, okay? So we know distance travel is 1/2 times acceleration times square. What is the problem here? We don't know the value of acceleration, so we need to calculate it from here, okay? So acceleration equals v minus v0 divided by time, okay? Let's go and calculate it for this part 1. Let's do here. Part 1, acceleration, final velocity, 40. Initial velocity, 0. Time taken, 20, okay? So 40 divided by 20 is 2 meters per square second, okay? So we go here, and we do 1/2 multiplied times 2 times time square. So time is 20 square, okay? 1/2 times 2, this is just 1. So this is just 1 times 20 square, which is 400. So we have 400 meters is what we move through in this first 20 seconds, okay? So this is 400 meters, okay? I'm going to erase this. And now we're going to go to part 2. So in part 2, it goes from 20 to 30 seconds. And is a uniform linear motion. So for uniform linear motion, distance travel is calculated in this way. So initial position 0. Velocity, what is it? It's constant, it's 40. So we say this is equal to 40 times time. So time is not 30. 30 is the time that it takes from the beginning to this. But we're only studying the uniform linear motion, okay? So this time is 30 minus 20 is this period of time. So this is 10 seconds. So 40 times 10, okay? Can you see that, guys? This is 40 times 10, so this is equal to 400 meters. So total is 400 meters plus 400 meters. That's equal to 800 meters. Okay, guys? I hope you could follow it.